Okay, so today we'll discuss non-parametric test using SPSS. Already have discussed parametric test, t-test and ANOVA. Non-parametric test basically the counterpart of those tests when the assumptions are not fulfilled. So today we will discuss non-parametric test, and after that we'll analyze some data using following the procedure. Okay, so
Okay.
the topic that I will discuss first, will discuss how can we use non-parametric test to compare two related condition, then two independent condition, then several independent condition and several related group. Okay.
Hmm.
So before discussing that, what is non-parametric test? Any idea you have when we use or name of any non-parametric test?
No.
Okay. Uh, you know what is parametric test and what are the differences between parametric and non-parametric?
I'll have to go through my notes again for this. I don't remember.
Okay, no problem. So parametric tests are those tests which follow or fulfill the assumptions. Two assumptions I told you: assumption of normality and assumption of homogeneity. Right.
Homogeneity.
So
Huh.
if the data follow the assumption of normality and assumption of homogeneity, then we can use parametric test. Parametric
Parametric.
test means
Huh.
t-test, ANOVA, or repeated measure ANOVA, or repeated t-test, dependent t-test, or if we use correlation, then Pearson product moment correlation. These are all parametric tests. Okay. Now, suppose
Hmm.
my data is not following the assumption of normality or assumption of homogeneity, or the sample is very small, and some small sample size is not the only criteria. If your sample is small and your data fulfill the assumption, then also you can use parametric. But when sample size is small, then there is a chance that my data will not fulfill the assumption. The chances like there's a huge chance that my data will not follow the assumptions. Okay. But generally,
Hmm.
when my data is not following the assumption, then we cannot use parametric test. If we use parametric test, then that will have effect on the power of the test, or on the data. We will not get data properly, or and sorry, we will not get output properly. Okay. So in that situation we use non-parametric test. So you can see I have write the definition of the concept of non-parametric test, that thing I have discussed here. Okay, so
Hmm.
basically non-parametric tests are assumption-free test. Means you don't have to make any assumption, and even if you have to make assumption, the assumption is very less. It's not like parametric test. You have to make many. You have to check the assumptions and everything. Okay, and mostly this test they use ranking. When I will discuss them in details, you can see in non-parametric test we use ranking. Like in Spearman rank difference is a non-parametric correlation. There we use ranking to check the correlation, not the score. Okay, we use rank. We use the score. We rank the score, and then we use the ranking to check the correlation. Okay.
Okay.
Now, there is one common belief that whenever I am using non-parametric test, then there is a chance that my statistical test like it has no power. Okay, or we think that parametric is better, non-parametric is not so much better. We have this kind of belief within us. This kind of stereotypical, or we can say prejudice. Okay, but it's
Hmm.
not like that. If your test is no, if your data is not following the assumptions and you use parametric, then your output, your statistical power will be less. But if your
Hmm.
data is not following the assumption and you are using non-parametric test, then it is fine. So we shouldn't have this kind of stereotypical belief or stereotypical or prejudice that okay, we should parametric is better and my data is not following the assumption, so I cannot use parametric test. This means my analysis is not. I'm not able to give good analysis or good output. It's not like that. Your data is not following the assumptions. Fine, use non-parametric test. No problem. Okay, it is
Hmm.
clear. So. Uh, this thing that just I discuss, I have written here, so I'm not discussing it. So first we'll discuss how we can use non-parametric test when we compare two related condition. Two related condition means within group design where we use same participant in both condition. Okay, like maybe it is a pre-post design. I want to see effect of any therapy on stress level of participant. So before administering the therapy, I take a pre-test where I assess the stress level, and after administering the therapeutic session, I again take a post-test to see whether there is any improvement or not. So in that situation, we use Wilcoxon signed rank test. This is the non-parametric counterpart of dependent t-test. Okay, I have written here. Okay, so we use this test when there are two set of score, but the score came from the same participant, and this is non-parametric equivalent of dependent t-test. So you have a data that is related data, and your data does not follow the assumption of normality and homogeneity. In related tests, will not check homogeneity like that, normality. Okay, in that situation, you have to use Wilcoxon signed rank test. Okay, so Wilcoxon signed rank test, like I said, is based on the rank difference. Okay, so what just I'm showing you what we do here basically. Suppose this is a test of break depression inventory. Okay, the tests were taken. Okay, so now what this test was taken Sunday, Wednesday, 2 days, and same participant. Okay, now before this 2 days, some drug was administered. Okay, now the researchers, they want to see whether there is any difference between participant when after administering the drugs. Okay, so what they did first, they calculated differences between these two conditions. Okay, and then this is a pre-test, this is a post-test one. So take the differences and then rank them. Okay, and then they calculate the positive rank and negative rank. Okay, so this is a way by which simply you just remember in Wilcoxon signed rank test, we calculate first the differences between pre and post, and then we calculate, then we assign rank, and then we use the rank to calculate the data. Obviously, when we are using SPSS, we don't have to do anything manually. We just have to click some buttons and the thing will come. But we have to know, we should have this awareness, we should have knowledge about this process. Okay. Fine.
Okay.
Now, how can we use this in SPSS? Okay. So these are the steps. I have written the steps, and I've also include the picture here so that when you when you use these slides, you can easily remember. Okay. Initially, now it is very confusing. We even now I have to sometimes refer my notes, my books to use SPSS. But when we practice it, then it will be much easier. Okay. So by that time, I will forget what was before and what is after, what I have used, I had used there. So it is better we always write the level so that we can remember. Okay. So this is our data. Now we'll go to analyze. Obviously, you have to check the assumption first to see whether it is fulfilling the assumption or not. So if it does not fulfill the assumption, then only we'll use non-parametric. But now I'm showing you the steps. Okay. So let's go to non-parametric, then legacy dialog, and then go to this two related sample. Okay. So then you will get this dialog box. So you can see two pairs are here. Just send them inside. There's an option exact. Okay. Now there is one thing. Okay. In exact, you can see there are two options, Monte Carlo and exact. Okay. So if your sample size is large, then you will go for Monte Carlo. And if it is small, then you will click exact. Okay. Just remember it. So here our sample size is small, it's 10, I guess only. So just click to exact. Okay. And then continue. Then option we have, click on descriptive. And if you want to see a quartile, then fine. If you don't want to see quartile, then you don't have to click here. So continue. Okay. And then click OK. So this is our table. Very simple. Non-parametric tests are very like they're easier one, and this is simple. This is our table. I will discuss this table. Before that, few things I want to discuss. You can see in non-parametric test there are few other tests there: sign, McNemar, marginal homogeneity. Okay, so this test are generally we don't use this test. That just we have to know that this why these tests are there. Like sign test is only based on direction or differences, means positive and negative direction. Okay, so magnitude is ignored here. So so this test has it has like it has less power. Okay, so like when we are using this test, this Wilcoxon test, we consider both sign and the magnitude, but in the sign test we ignore the magnitude, only focus on the sign. So generally we don't use it. Okay, then McNemar test, when it is we use when there is nominal data. If your score are nominal, then we use this scale. Okay, and marginal homogeneity, it is another test of is an extension of McNemar test, but it is for ordinal variable. But generally the same like Wilcoxon test. So just you have should have knowledge. That's why I have included this slide. But simply when you are doing non-parametric test, simply it is by default. You can see it is set. It is by default non. Sorry. Just a minute. Let us have Wilcoxon is here, so you don't have to do anything else. Just click here and set the option from exact an option and click the OK button. Is it clear? Okay. Any question? Any question?
Can you open the options wala tab?
Yes, just a minute. Non-parametric. Where is the dialog? Option. Here only you have to use descriptive.
Okay, the descriptive ones.
If you have any missing value, then you have to consider this one. Otherwise, just leave it as it is. You don't have to do anything. Okay. I have included here in the slide, I think. No, option wala I didn't include it. I only included this one. Okay. Fine. Okay. Another way you can calculate, which I have not included in the slide, but I will when I will send you. Okay. I'm just showing you. Go to non-parametric legacy dialog. Sorry, non-parametric and related sample. Okay. Then go to field. Then send them here. Then click. Okay. So setting. Right. Okay. We don't have Wilcoxon sign test. Wilcoxon HPR. Okay. I have to click this one. You can do this. The one thing which is like here, it is clearly written what I have to do: reject the null hypothesis or accept the null hypothesis. Otherwise, you can follow the previous one, which is that one is much better. Okay. Clear? Clear?
Yes.
Okay. So this is our table. So let me explain the output table. First one is the descriptive statistics. We know the mean and mean, standard deviation, maximum, minimum we have here. Second is rank. You can see negative rank, positive rank, sum of rank is given here. Okay. Like this I have mentioned here. So nothing different, nothing in significant is here. This is important, Z score. Okay. You can see the Z score is minus 2.5. Okay, so minus means there is in the pre measure the score was more than the post measure. Okay, And significant, we have to consider the exact significant. Now, if I want to use two-tail test, means I don't want direction, I only want the change, want to know the change, then I will use two-tail this one. And if I am interested to know the change also, then I will use exact significant. Okay, that's up to my research question. So here I can see that this is significant. Okay, this is significant. I know this is point. If in all cases it is significant. Okay. So what I can say from the statistics. Okay. So one thing, like I said, it is minus. You can see the Z score is in minus. Okay. So so we can say that in the the particular drug may increase the stress level, may have increased the stress level, because it is minus. May have decreased the stress level. Okay, because when we are calculating the rank, hope you can see here. Okay, we are taking differences from post to pre, means 28 minus 15. Okay, so if you can see here. Okay, so if it is in minus, it means this one is less than this one. Okay, so you can see that, yes, no, is it gain? If it is minus, the score is in minus, so it is less. Okay,
Yes.
it is decrease in the score. So BDI means depression inventory. So we can say that the depression is increased. The depression has increased from the negative side. Okay. After taking the particular drug, maybe. Is it clear?
Yes.
There is negative sign, so depression has increased from the previous state. That we can say. Okay. Value is based on the negative rank because it is the smaller of the positive and negative rank, the majority rank must have been positive. So we should conclude that when taking ecstasy, there was significant increase in depression the morning after midweek. Okay, so you can see in Wilcoxon sign rank test, both magnitude and the sign, they are important. Is it clear? So that is the reason why we use that, not other, because it has more power than other options like this test. Okay. Now, obviously, we have to calculate effect size. So just we have to use this formula. R is equal to Z n root over n. Where n, Z means the Z score we have, and n means the total number of observation in two conditions. So here our n will be 20. Is total number of observation in two conditions, not number of participants. Okay. So how many observation we have in pre measure we have 10 observation, in post measure we have 10 observation. So total observation is 20. Is it clear?
Yes.
Okay. So this is the way, by using this simple formula we can calculate the effect size. Okay. And whenever you are using, so you have to write the Z score here, and then the 20 root over 20, and then you will get the effect size. And then you have to multiply it with 100, then you will get the percentage. Okay. And we know that if it is more than 50%, then we can say it has large effect size. Is it clear? Wilcoxon test?
Yes.
Non-parametric tests are comparatively easier than ANOVA, right? ANOVA and t-test. Okay. Now, next we'll discuss. Just you have to remember that which test you have to use when it is independent, which test you have to use when it is dependent, because sometimes we get confused. Okay, that's it. Okay. Otherwise, it is not like these tests are very easy. So comparing two independent conditions. So we have discussed how we can compare two dependent conditions. Now we'll discuss how we are going to use two independent conditions. So we will use Mann-Whitney test for this. Okay. Mann-Whitney test for this. Now, so if we want to test the differences between two conditions, then we use Mann-Whitney test. Mann-Whitney test is a non-parametric equivalent of independent t-test. Okay, so we use Mann-Whitney when we have two separate groups, like between group design. It is clear?
Yes.
So Mann-Whitney also use rank like Wilcoxon test. So we rank the score and then we check differences between rank, whether it is significant or not. So I'm not discussing the theoretical background again. I'm just
Hmm.
going to the calculation part. Okay. So you can see the steps here. These are the steps.
Hmm.
So just let me clear this data first. So, like independent t-test, when we have to enter data for Man-Whitney, we have to use coding. Okay. Oh no. Like this way, 0101, we have to use coding. Okay. For this data, when we need two groups, so I will not use this column. We need two groups, 0101. So suppose I want to see difference between two groups on something, on maybe emotional expression. Okay.
Hmm.
So my dependent variable is emotion, and my independent variable is maybe it can be gender or something else. Always we use gender. I'm just thinking something else.
Use
Maybe
gender if you are keeping only two this groups.
yes, uh, yes. Say
No,
something.
I was just saying. I was just saying since you are said we'll keep two groups, so I guess gender will do.
Gender will do. I was thinking now always we use gender. So I was thinking something else if we can do. Okay, maybe we can use emotion and
We can do
maybe we can
extrovert.
use personality type. Yes, we
Hmm.
can do. Yes, group. And in the here we can write personality type to the level. Yes. And we can denote the values here. Maybe 0 for introvert and 1 for extrovert.
Extrovert.
Okay.
Hmm.
So this is our data. Now we want to use non-parametric Van Whitney again before using before deciding whether I'm going to use Van Whitney or independent t-test. We have to check the assumption. If the assumption, okay, so go to non-parametric legacy dialog and just two independent samples. Now test variable emotion, grouping variable one, and you have to define your group here. Group 1, 0, group 2, 1, 20. And you can see other options are here. I will tell you about this option later, but by default, Van Whitney is activated, so you don't have to do it, you don't have to change here. Okay, we'll use Van Whitney
Hmm.
always. If it is specifically mentioned or if your research question required other test, then only you click other test. Otherwise, we'll use Van Whitney. Then go to exact. Same thing. If your sample size is large, you will use Monte Carlo. If it's small, you will use exact. So here our sample size is 30. So it is large. We'll use Monte Carlo option. Okay. Exact.
Hmm.
So click on Monte Carlo. Continue. In option, same thing. Descriptive. Continue. And then click OK. So this is our table. Okay. You can see the differences are here. Man-Whitney test. Okay. Okay, I will come to the output table. Before that, I have written all these steps here. Okay. So I'm not describing it. So you can see three tests are here. Kolmogorov-Smirnov, we know we use it to test. It is Kolmogorov-Smirnov Z. Okay, so it is a kind of test we use to check normality. So you can say uh, this test we use when the sample size is less than 25. Okay.
Hmm.
So if the sample size is less than 25, so we will have better score if we use this one. Okay. Moses Extreme, it is another test. So it is now like non-parametric level test. Means when we check the normality assumptions. Okay. Generally we don't use it. And another one, this one, World Ulfwitz run. Okay, this is another test. It actually look at the. It doesn't use rank. Rather, it uses a rank, but it just a minute. Okay, it check at the score. Okay, which means it does not calculate rank differences like that. Okay, we just use the score of the same group and then we rank them and then we check within that group there is any difference between rank or not. So generally we don't use this test. If your score is less than 25, you can use this one Kolmogorov-Smirnov Z test. Otherwise, you can use Mann-Whitney also. Is it clear?
Yes.
Okay. So just simply click Mann-Whitney and you don't have to focus on the other test. Okay. Just a minute. So this is the output table. So as I told you, this is a descriptive test, descriptive statistics. We have mean, ST and everything. Then we have rank. Okay. Rank, mean rank, sum of rank. Okay. Now this one, sorry, statistics table. We can see the Z value. Okay, and here will okay, this one the sample size was less, so I use exact significant. But here we have used Monte Carlo, so we have one tail, both one tail and two tail. Again, if your research question want one tail, you will use one tail. If it wants two tail, then you will use two tail. One tail test means when direction is important as well as the magnitude, and two tail means only magnitude. Okay, so we can say it is not significant. In either case, it is not significant. So there is no significant difference between these two groups. Okay, clear? Okay.
Yes.
Now, same way we have to calculate effect size. The same formula we have to use. Z minus root n. N means total number of observation in two conditions. Means here also your n will be a combination of two conditions. Means 20. We not 20. Sorry. Here it will be 30, 30, 60. Okay. Clear?
Yes.
So this is the simple formula you have to use. Okay, so we have discussed two related sample, two unrelated sample. Any question?
No questions.
Okay, fine. So now we'll discuss comparing several independent condition and the Kruskal-Wallis test. So when we have several independent conditions, so we use Kruskal-Wallis. It is non-parametric counterpart of ANOVA, one-way ANOVA. Okay, so if we have three separate groups, three group of individuals A, B, and C, and I want to see the effect of differences between these two groups on anything, then we'll use Kruskal-Wallis if the data does not follow the assumption of normality. So suppose I want to see the differences of emotional reaction between three types of personality, maybe introvert, extrovert, and neurotic. Okay, and my data does not fulfill the assumption. So in that case, I cannot use one-way ANOVA. I will use the non-parametric counterpart, that is Kruskal-Wallis. Okay. So this test is also based on rank data. So we don't consider the group, we just rank them. Just let me show you here. Can you see it? Okay. Is it visible?
It is visible, just not
Okay,
very.
just
Yeah,
this one.
now it's better. It's readable.
You can read
Yeah.
now. So you can
Yes.
see three groups are here. This is our test. That that was that the test was like the objective was to see if there is any effect of soya milk on sperm count of male. It's a test based on biology. Okay, so you can see three groups are here. The groups who individuals who do not drink soya milk, and other groups like 1 soya milk per week, 4 soya milk per week, 7 soya milk per week. Okay, and these are the scores. Fine. Now you can see they have ranked when we'll calculate Kruskal-Wallis, we will not consider the group separately. We'll rank them without considering their group. So in here, this is rank 1, rank 2, okay, and then this is rank 3, then this is rank 4. You can see, you get my point now?
Yes.
So we are not doing it within our particular group. Rather, we are taking all group together, and then we will assign rank accordingly. It means in group 7 we have lowest score, so that is will be 1. Okay, then the next highest score in group 7 again. The next highest score in groups 2, that is 3. The next one is group 4, like this. Okay, so in this way we have total 80 rank. Is it clear?
Yes.
Again, when we are using SPSS, we don't have to do anything. We just simply we have to click some button, but we should know how we are doing it. That's it. That's it. Okay. Is it clear now? And then we'll calculate the summation of all this rank, and we check the differences and all. Okay. Basically, this is a theoretical part. Is it clear?
Yes.
So now we'll go to the steps of Kruskal-Wallis. The same steps. Yes. Same data. Okay, so now we need 3 groups. So I will delete this one. Now we have 3 groups. Okay. So it is a variable, maybe level of anxiety or stress. Okay, let me use some positive psychology, variable for positive psychology. Maybe subjective well-being. Okay, and groups maybe 3 individuals from 3 type of who experience 3 types of parenting. Okay, so parenting style, maybe my level, then values, and here 0 means maybe authoritative parenting style, and denoting it AR. Okay, then 1 means maybe authoritarian. You know na parenting style.
Yeah, I remember liberal and authoritarian. Like one of my classmates had that as one of the variables for their dissertation.
Okay, yeah, parenting style. You know that
Like 5, I think.
authoritarian parenting, democratic parenting, and authoritative parenting. Okay, these are different types of parenting style. Okay, I'm not giving you much information now because it's not our class on parenting style. Okay, so the different types of parenting style. Just remember it. Okay, now 2 is maybe democratic, or no, not democratic. Maybe authoritarian. And yes, maybe laissez-faire parenting style. Fine. So okay, 3 group of parenting style. Now go to data view. We have 3 groups here. Fine. I have level here 0, 1, 2. No? Okay, fine. Now we have to go to analyze, non-parametric test, legacy dialog, then this K independent samples. Okay. Send your variable here and group here. Here we have to define range. Means 0 and 2. This range, maximum and minimum. Okay, so if you have 7 groups maybe, so it will be 0 to 6 like this. Okay. So, okay, here we have three options: median, Kruskal-Wallis, and this is a test, Dockery-Trubster test. Okay, so this one I will click. What is this test? I will tell you a bit later. Okay,
Okay.
then go to exact. We have sample size. Okay, again, I forgot to check. We have 30 sample, right? So we'll go for Monte Carlo.
Monte Carlo.
Okay. And then option, descriptive, continue. Okay, now, so I have written here, so large sample Monte Carlo, small sample exact test. Okay, so these two options we have. One is median test. When we use median to calculate our data, generally in Kruskal-Wallis we use mean. Okay,
Hmm.
same we if somehow we don't have mean and we are using median. Uh, Oh, sorry. When we had using sample, we have same median from a population. We have same median, then we use median test, but generally we use Kruskal-Wallis. Okay, and this one is important. Jocheri-Trubster test. This is we use to see any trend, if there is any trend in data. Okay, so like the example I discussed, soya milk. I want to see if there is any trend, like with increase in milk intake, is there any increase in sperm production? So that is there we want to see a trend. So for that reason, you have to use this test. Okay, so suppose in this example, if your data support this thing, then only you have to click here. Like subjective well-being and parenting style, here we don't need to see the trend like this. Maybe still I have clicked here, but if your research question is like this, like the thing I discussed, in that situation you obviously need to see the trend. Am I clear?
Yes.
Okay, so that's after your research question. So this is called Jocheri-Trubster test. Okay, I will come to it a bit later. Much other informations are there, which I will discuss with output table. So let me click OK button. Okay, so you can see this is a descriptive statistic table. These are the rank of three groups. We can see. Okay. Oh, one more thing. Okay, now I remember. I just told you one thing. Here, when we are calculating effect size, it will not be 60. It will be 30, because in parametric independent sample, all observations are in one column. Now, am I
Hmm.
clear? It will
Okay.
be 30, not 60. Okay, clear.
Hmm.
Okay. So this is the rank. You can see rank of three groups we have, and here we have the uh, z value and the significant value. So we can see it is not significant. If we consider the Monte Carlo, it is not significant. Even we consider the asymptotic significant, it is not significant. Okay, then this one is important when we are using trend analysis, especially. So this is the table. Some things are here, like we use this test to see if when we are comparing median of the group. Okay, and in this test we focus on the z score. This is the z score, number of this one is z score, this one. Okay, this is z score minus 1.046. Okay, and it is always one tail test, because in this test sign is important. So even if you can see there are two significant, one tail and two tail, just focus on the one tail one, not the two tail one. Okay, clear.
Hmm.
And now why
Yes.
it is, you can I have written in this point, the sign of the z is very important. If the sign is positive, it means ascending trend, means with your median get bigger with the value of the coding variable. Means your coding variable means 0 1 2, so your median will get bigger with it. And if it is negative, it means your median, it is there's a descending means median, means your median will get smaller as the value of the coding variable get bigger. Okay, is it clear? So here
Hmm.
in this data, this value of z score is negative. It means my median will get smaller as my coding variable get bigger. Means there is a negative trend. Is it clear?
Yes.
Means if we use a straight line, so when my coding variable is 0, my median is less, and as it is increasing from 0 to 1 to 2, it is my median is also increasing. That is ascending trend. Okay, and descending trend means when my value is median is decreasing while my coding variable is increasing. Okay, so you can see why it is important, and it is why it is always one tail test, and why sign is important. So in certain tests, when we want to see the trend, so we can use this test. Suppose I want to see there is any change between in particular in preference to a particular style, particular genes, maybe particular type of genes across different generation. Okay, so maybe I have taken sample from 80s, 90s, and post 90s. Okay, so and I check whether there is any change, or if there is any particular trend. In that situation, we can use this test. Okay, is it clear?
Okay, yes.
So this is our you can see in this test here also it is negative. So this is a descending trend. So we can say that emotional expression may be decrease with what I say, with my grouping variable. Okay, grouping variable 0 means like authoritative parenting. What are my grouping variable? I forgot it. Okay, 0 means authoritarian parenting or authoritative parenting. So I may conclude that there is a trend that with increase in laissez-faire parenting, with increase in grouping variable, there is a change in there is decrease in subjective well-being. Okay, but generally in this, for this particular type of problem, we don't have to check trend. There's no logic, I think. Okay, generally we see trend analysis we do when we want to see there is a change throughout the time period, or because of some drugs like this. Is it clear? Not for
Yes.
this particular problem. Okay. Okay,
Hmm.
then we have to calculate effect size. So we don't have any separate formula for calculating effect size. So for this, we can calculate effect size. We have to calculate. Okay, before that, I have to discuss the post hoc. Then I can explain you. Okay, post hoc test. There is no separate post hoc test. We can calculate Mann-Whitney test. Mann-Whitney, hope you remember, we use in if we have two independent sample, right? So that Mann-Whitney we can use to test differences between groups, to pinpoint the differences between groups as a post hoc test. Hope you remember what is post hoc test.
No, you'll have to
No.
say this again.
Okay, I'm telling you.
I remember
Suppose
it was like one of the tabs when we were calculating.
no, it's not that. Okay,
Okay, it's a
post hoc test
different
means,
one.
yeah, post hoc test means when we are calculating ANOVA or Mann-Whitney, okay, any test. So we can say that there is significant difference between means. Okay, so suppose I have 5 groups or 6 groups, I can say there is significant difference between me. But which two group are different from each other? That we have to point out, right? So I
Okay.
have group A, B, C, D, E. Okay, and I will say this group they differ from each other significantly. Now, which two groups are different from each other? So we use post hoc test to check that. What is that significant? Whether A differs significantly from B, or B differs significantly from A, or B, like this. Okay, in all combination between two group, and we have to pinpoint that which two group differ from each other. Right. So that is the
Hmm.
reason why we do post hoc test. Now, like last class we discussed that we can do t-test to check the posters easily. But if we do that, there will be a thing I have explained you, that inflated error rate. Hope you remember that the type 2 error will increase. Sorry, type 1 error will increase.
Hmm.
You don't remember? Okay, let me show
Hmm.
you the
Like,
slide.
I have to go through the notes and the videos
Okay.
again.
You don't have to. I'm showing you the slide. Just a minute. We discuss it under 2 means, I guess. No. ANOVA. Comparing several means. Here we discuss. Just let me show you the slide, then you can remember. Okay, this one.
Hmm. Oh,
Okay.
yes.
Okay.
Hmm.
So if suppose I am calculating ANOVA, or I'm calculating I'm calculating Kruskal-Wallis. This one, the one we are discussing now. Okay, this one, this test. Okay. So in both cases, we are comparing more than 3 means, right? And in post-hoc test, we have to know, we have to pinpoint uh, which two groups differ significantly. It may happen all groups differ significantly from each other. It may happen only maybe two groups or one group differ significantly from, two groups or four groups differ significantly from each other. So we have to pinpoint the exact point where the differences lie. Okay. For that reason, we calculate post-hoc. Now, when we are doing ANOVA, if I use t-test to calculate post-hoc, and there is a chance that that will increase the type 1 error, like I discussed here in this slide. Okay.
Okay.
This one. So, if I use t-test, then there is a chance that there will be increase in type 1 error, 5% to 14.3%. I discussed this one. Hope you remember.
Yes.
Okay. Now, same thing can happen in non-parametric test. If I use here, if I can use Mann-Whitney test to check differences between two groups. But if I do that, then that will again there is a chance that type 1 error will increase, and which we don't want. Okay. So what we can do to control this problem or to handle this problem, there is a correction called Bonferroni correction. Let me show you this slide. Okay, Bonferroni correction. Okay, here what we do, simply we divide the critical value. 0.05 is the critical value we generally use. Okay, so simply divide 0.05 by number of tests you have, number of groups you have. Okay, so divided 0.05 by number of tests you have conducted. So suppose I have 3 groups, then I will divide this critical value 0.05 by 3. Then I will get another value. This is another value. And now when I will calculate Mann-Whitney test, I will consider this value to check whether there is, to check the significant level. Okay. So let me explain it another way. Suppose I have 3 group A, B and C. I have calculated Kruskal-Wallis to see whether the group differs significantly from each other or not. And I find that the group differs significantly from each other. Now I want to know where the differences lies, whether it is between A and B, whether it is between B and C, or whether it is between A and C. Okay. So for that I have to do post-hoc test. So what I will calculate simply Mann-Whitney. We don't have any separate test for non-parametric like we have in parametric. So we simply calculate Mann-Whitney test. Okay. But if we do Mann-Whitney test, then that can increase type 1 error. So to control that, what we'll do a correction which is called Bonferroni correction. So we simply divide the critical value that I will use to check the significance level, that is 0.05, by number of tests we will conduct it. Okay, so here we'll conduct 3 tests to check that significant difference. So just simply divide it by 3, and the value we get after that we'll consider. Now we'll not check the value of Mann-Whitney by using 0.05, rather we'll check by using 0.167. Okay, so now it will be, this one will be my level of critical value. Is it clear?
Yeah.
Okay. So my suggestion is that whenever you are using any kind of statistics, just go through your slides or book, whatever you have, properly, and then follow the steps. Okay, it's not possible for you to remember. Okay, and it's not possible for you to, no, you can remember, but you need a lot of practice. And it is always better whenever, like, you can't, like, it's not something that we will bag up and we will write. You have to understand it, you have to know it, how to use it. Okay, so it may happen that when maybe tomorrow you not remember how to do that thing. Okay, so simply go through the slide and then do your calculation. That will help you. Whenever in future you will do analysis using SPSS, go through the slide. Okay, and I have shown you, you have option here in SPSS. the help option. Okay, so
Help
if you have internet,
option. Yeah.
you have internet connection, you just click on the help option and you will get everything there. Everything, all means all the background theoretical part is there. Okay,
Hmm.
is it clear? So in this way, we'll calculate the post-hoc test. Just simply divide the 0.05 critical value by 3, and the score you will get, that will be your value that you use for the significant test of man-Whitney. Then there will be there will be like no chance of inflated type 1 error. Okay,
Hmm.
clear? Okay.
Yes.
So, and calculating effect size, you have to use effect size of Man-Whitney test. That simply the way you have done in the Man-Whitney test, this formula z minus root n. Okay, sorry, z by root n. This one. Here also you have to do that. For when you have 3 groups, you are for post-hoc test you are using 3 separate Man-Whitney, and for that you have to calculate 3 separate effect size. Is it clear?
Hmm.
Okay. Yes or no? Please tell me. Is it clear or not?
No, like it is clear, but then I will have to listen to the lecture again and again to like be thoroughly clear with it. Like when you're
Yes,
just
yes, yes,
to
yes. You
understand.
have to. Yes, yes. It is that you have to go through the lecture. You have to follow the slide. I have prepared the slide in a way. Once you suppose you are calculating a Man-Whitney test, you go through the slide. You will understand.
Hmm.
Okay, you don't
Yeah,
have to.
and
You don't have to then just follow the slides. I have written everything here, and what I did that in book many things are there. I have written the main points so that you can easily find and you do your calculation.
hmm.
Okay, so simply when you are suppose 3 groups are there, A, B, and C, and you want to check the effects in post-hoc test. So you will do a Man-Whitney test, 3 separate Man-Whitney test, right? Man-Whitney
Hmm.
between group A and group B, then group B and group C, and then A and C, right?
Hmm.
Is it clear?
Okay.
And you have to calculate 3 separate effect size to see the effect size of this total calculation. Is it clear?
Okay.
Okay.
Yeah.
And using that same formula. That you have to do obviously manually, not in SPSS, or you can use calculator. But this is in this way you have to do. So is it clear now?
Yes.
So last we'll discuss comparing several related conditions, that is Friedman analysis, Friedman ANOVA. Okay. So
Hmm.
Friedman ANOVA is the non-parametric counterpart of repeated measure ANOVA or one-way repeated measure ANOVA. Okay.
Hmm.
Same thing when the data they violate the assumption, we use it. Okay.
Huh.
So this is the thing. Here you have to rank. This is different individuals. Okay, and this are different conditions. Okay, and now you have to rank them. These individuals you have to rank them. Okay, here we have to consider this is the this is a different condition, so you have to rank them like this. Clear?
Hmm. Okay.
So in SPSS you don't have to do it. SPSS you can do it like the SPSS will do everything. You just have to click the button. So same process. Okay. Now file import data. Oh, this one I have used now. Just a minute.
Hmm.
Sometimes it's okay, confusing. This one is much. So this is 3 related conditions. So you have to write our data in this way. Okay. So go to analyze, non-parametric, legacy dialog, key related sample. Send your test variable in this side. Okay. Prideman already by default we have here. So just you don't have to do anything, and I will come to these two tests a bit later. Then exact test. Okay, sample size is 14. It is less, so we'll go for exact. Okay, continue. Then statistics. Go to descriptive. Continue. Then click OK. So this is our table. This is the descriptive table, rank table, and this is the Z squared table. Okay. So it is it is not significant. You can see it is not significant. Okay. This one is so simple. We don't. Kendall W. This is like Prideman ANOVA. This is generally used when we have raters. Okay, like we use rating. In that situation, we use Kendall W. Okay, you can see here we asked one example is here that researchers they asked 10 different women to rate attractiveness of 3 individuals. So in that situation, we use Kendall W. Okay, and Conran Q. It is another test when data is dichotomous, means when we have yes no data. Okay, yeah, the response is yes or no. In that situation, we use this one. Okay, so just remember when you have rating, when we use Kendall W, and when we have yes no dichotomous variable, then we use this one. Clear? Now, this is the output table. I have already discussed that descriptive table. We have rank, statistics. Okay. Post-hoc test, exactly like the previous one. You have to calculate different Wilcoxon sign rank test between each condition. If you have these three groups, then you have to calculate the Wilcoxon sign rank test between 1 and 2, 1 and 3, and 2 and 3. 3 and then you have to do a Bonferroni correction, means you have to divide the critical level 0.05 by number of comparison. So here we have 3 comparison, you have to divide it by 3. Okay. If we have 5 comparison, you have to divide it by 5. Then you have to use that product to that product will be your new level of critical value. Okay. Clear? Exactly like the previous one. Then for effect size, same thing. Here you have to calculate effect size of Wilcoxon sign rank test. So if you have 3 conditions and 3 separate tests you are conducting, for Wilcoxon sign rank test you are conducting, then in that situation you have to calculate 3 different effect size. Okay. Okay. So these are our non-parametric test. Any question you have from non-parametric?
No.
Okay, fine. So just go through the slide. I will send you by Monday. Okay. Just go through it, practice it, and even if any question, you can contact me anytime. Okay. So now I will do 2 tests properly. Means we'll start from the beginning, like we'll do the take the assumptions, and then we'll decide what we'll do. And obviously you are going to, I will help you. It's not a test, but I want some, contribution from your side. Okay. So
could you just give me 2 minutes? I'll be back.
okay, just let me know when you are back. Okay.
Yeah.
So suppose I want to see, suppose this is a related test, okay, sorry, within group design, and 4 condition you can see here, pre, post 1, post 2, post 3, okay. So in let me go to the variable view. Okay. So here in level we have to mention means what pre and post and Means what we measure in the pre, post one, post two test. So that we have to mention. So suppose I have, because again, suppose I again open this file after this output after 6 months, and by that time I will forget. Okay. So suppose it is a test where I am trying to see whether there is any effect of therapeutic treatment on emotion. Okay, or on emotional expression. Okay, or suppose on stress simply. So just write level here, stress. That's it. Okay, I don't know why it is written here. Okay, and you have to arrange your data in this way, otherwise no, when you will calculate analyze your data, the species will not take it. Okay,
Huh.
a is your variable. Okay, and okay, it's better if I write it S. S, so it will be more meaningful. S is the short form of stress, and this is a different measure of stress. Underscore. Hope you remember in first class I told you that here you cannot give any space. Okay, if you
Huh.
give a space, then that thing will come error and like that. Okay.
That invalid character.
Yes, and character. Okay. So now this is the data view. Now, first what we have to do, we have to check the
Yes.
frequency and descriptive statistics. So go to frequency. Then
Put it on the other side.
okay. Every time I forget, now I remember. Create
Yes,
epistat table. That
APS.
yeah, that will no for our own convenience. We have to click here. So now go to statistics. Here, mean, median, whatever information we want. Mean, median, then skewness and kurtosis. Both of them are important. Then
Standard
minimum,
deviation.
maximum, variance. Then even click if you don't want. Don't click. Okay. We'll continue. One thing we have to remember when we are calculating, many times we'll click all of them, but we have to, think which things we need, because if too many informations are there in a table, it will be very confusing, especially when we are using many variables or many different groups are there.
Hmm.
We'll continue. Okay. Then okay. So this is our table.
Hmm.
This is our table. Okay.
Yeah.
Then we can see the skewness, the skewness. Okay, curtosis, everything we can see here. Okay. Now we'll go to the graph section.
Hmm.
So
Graph.
legacy, legacy
Legacy.
dialog. First, I will do box plot, because if there is any outlier,
Huh.
we have to
It's
transform
the
data.
box
Okay.
plot.
So we'll go to simple box plot, and this is a separate
Separate.
variable, not cases. No, separate. Okay. Just let me check. Dialog box plot. Okay. Separate variables. Different option. Complete anything. Then click OK. So here we have one outlier in here. It's thing 27. Okay. Otherwise, we don't have much outlier. So now it's up to you what we want to do. Whether we want to, check there's any, 27. Let me see the score. Okay, this is an outlier.
Hmm.
Okay, otherwise we don't have any outlier. Now it's up to us what we want to do. Whether we want to change the score, we can check. Many times it happens that there's a typing error, or if it is not, then we have to use a transformation phase. Okay, we have to transform all the score and everything. Put variable and do the transformation. So now right now I'm not doing it. So let's check the assumption first. Okay.
Mm.
Go through analyze descriptive statistics. Then okay, another graph we can do histogram. Sorry, yeah, histogram we can do also if we want, or we can do it after also. It is not important right now, but we need graph for to report our data. So obviously we'll do draw histogram, but first we'll check the um, here the explore. Then send your variables in this side.
Okay.
And plots
Normality.
normality, and then click OK. This was test of normality. So these are all significant. You can see. So means okay, sample size. Okay, in normality test, sample size is less than 50. Then we'll consider subequivalent, right? Here our sample size is less than 50,
Mm.
70. Okay, so we'll use Kolmogorov. Yes. Consider Kolmogorov. Now, if we consider Kolmogorov's one of test, this test then also they are significant, right? So here we have to use non-parametric test. So you can see even if our sample size is 70, okay, still we
Mm.
have to use non-parametric test here.
Mm.
So non-parametric test, analyze non-parametric test, legacy dialog.
Yes.
This
Yes.
is K related sample.
Okay.
Then side menu have to do. Take a look.
Mm.
Statistic descriptive we already have, so I don't. So you don't need it anymore. Or if you want, you can. Oh, okay. Oh, descriptive we have to give because
Huh.
we have total score. Okay, then click OK.
Okay.
So here this is the score we have, and Monte Carlo significant. This is significant. So there's significant difference between this score. Now we have to calculate to check the post hoc test. We have to calculate again two
Legacy.
related sample. Okay, and we'll take the pair here. First stress, first variable versus
Second.
1, then
Huh.
1 versus 3,
Mm.
then 1 versus
The last one.
4. Okay,
Mm.
then 2 versus 2 and
The
3.
last one. Huh.
We have taken all pairs, right? 1 2, 1 3, 1 4. 2,
Huh.
no. Uh, one variable pretest post-test 1, pretest
Mm.
post-test 2, pretest post-test 3. Okay, then post-test 1, post-test 2, post-test 1, post-test 3, one more, post-test 3, post-test 2 and post-test 3. I think now we have all pairs. Pretest, now we have all pairs, right?
Mm.
Okay, just click then. Or duplicate pair we have. Okay.
We had done, like you had done it before.
Yes. Okay, let me start it from the beginning.
Okay.
Stress E and post 1. Right. Then free and post 2.
Two,
Free
three,
and post
post
3.
three,
Okay. Then post 1,
one, post
post 2. Post
post
1,
one, post
post,
three,
yes. Then post
post
2
two and three.
and post 3. Now we have, yeah, we will have 6 days. Now it's fine. Okay. So you can see this is the table we have. And now here we have to consider the, okay, that one will SPSS 2, I guess. Okay. Oh, this is the mean rank. This is the statistic table. We have to divide it by 6 number of tests we have conducted. In each case, we have to do that.
Yes.
Is it clear? And here we can clear. And let me draw. Here we can draw line. There is changes now. Summaries of separate variables, simple line, separate variable. Line represent. So, so between pre and post 1, no change. AB and after sequence increase. Okay. So you have to decide for your as per your research problem that what kind of graph is suitable. So pre-test, post-test. So there is a like we have to see the changes, right? We
Okay.
use it line graph than bar diagram, histogram. Okay, so that's why I selected line graph. So you can between two condition you can explain that also from this graph. Okay, and you know use this graph to support your finding. Is it clear?
Hmm.
Okay. So we'll do one more calculation. This is repeated measurement. Then we'll do one independent test. Okay. Is it clear? Any question you have?
Uh, no, I just got a little confused. There was another test to check normalcy or homogeneity, right? You said to check two
Yes, yes, yes.
functions.
No, 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 no. Okay. When you are calculating repeated measure, you have to check normality first
Huh.
using this explore option. And
Hmm.
for homogeneity, we are using same sample, remember. So it is expected that they are homogeneous because they are same sample. But
Oh,
when we are doing ANOVA, there is option for test. So in this particular problem, we did non-parametric, so we don't have to do that mutually test of sphericity. Okay, but if you are doing ANOVA, then you have to do the mutually test of sphericity, which is actually the homogeneity test, homogeneity between the differences. Let me show you. Suppose this test fulfill the assumption. Okay, so go to analyze. Suppose I want to do ANOVA, so I have to use repeated measure ANOVA, right?
hmm.
So, okay,
Okay.
I have to change. Okay, repeated measure ANOVA. So this is my factor S, and I have 4 levels here. So added. Okay, measure. Let's write the name. Press here. Add it. Define. Okay. Here you will find. Sorry, not here. Options. Homogeneity test option. This is
Hmm.
actually the test which measure sphericity or the homogeneity between the differences between each condition. Okay, so we don't have to calculate homogeneity separately for like we'll not calculate homogeneity for in the explore section. When we'll do ANOVA, we'll calculate. We will click this homogeneity test button. Then it will show the mutually test or sphericity table, which indicate the differences between each condition they are homogeneous or not. Okay,
Okay.
because the data, the score, they will be homogeneous. It is expected because they are same individual. They are not
Hmm.
different individual. Okay, but we have to know whether the differences between each condition is homogeneous or not. So that will test by usually test as sphericity. Is it clear?
Yes.
Okay, one more thing here, as we have outlier, we cannot ignore it. I ignore it in the present problem, but when we are doing analysis in real situation, either you have to, ignore the score, or you can do one thing we can do here, which is easier than transformation. Like, if we have many outliers, then obviously we have to do transformation. Okay, but here we
Hmm.
have only one outlier, so for only one data I cannot change all, I cannot do all, I will not do that thing. So I can do one thing, like can take the next highest score and then add one. That I can do, and then I will do the calculation.
Hmm.
Okay, so this if we arrange the variable in descending manner, so next code is 221, so I can replace it 221. Okay. Now if I use a box plot, just let me show you. Let me check if it is fine or not. Legacy diagram, box plot, samples. Just only this one I will check. Okay,
Okay.
those three. Okay, so I can see now it is controlled.
No, huh? No
Okay,
outliers.
no outliers. So only for one data, I will not do all the transformation because many things we have to do. We have to change the score, and it's very complicated one. Now, if I have many outliers, then obviously I have to do. I have to transform my score. But this is a easier way we can do. First, I have to check whether my score is, whether there is any mistake on my part. Then I can do that. Okay, it's better than, also I can, another thing I can do, I can ignore this particular data, but you know it is very difficult to collect the data, so one single score is very important for a researcher. Okay, so why I
Hmm.
will ignore the data, I can do that, this thing, and this is not a manipulation. Okay,
Oh.
okay,
Hmm.
means it is not something which is wrong. It is a procedure. You can see the slides. It is written there. We can do that. Okay. Now
Huh.
one thing, always remember, we are like in the course or any book, you know the rules that okay, if it is like this, you have to do that. But when you are doing analysis, is up to you. Like suppose I have to check the assumption. So when I am doing the analysis, is up to me what I am going to do. If I think that okay, even if I have found one outlier, I will transform all the score, then I can do that. Okay, it's not like that this wrong. So in that moment, you have to take decision, and the thing is that you have to, obviously you have to follow the rules. Like if the assumptions are not fulfilled and you use non-parametric, that is wrong. But in some cases, you have to take decision in that moment. It's not possible for any book or anyone to tell you that what you have to do. That your own decision, and whenever you are reporting your data, you have to logically
Yeah.
explain that
Um,
why you are doing this, why you are not doing that. Okay, that's up to you. Clear? Am I clear?
yes.
And if it is if it is logically like if you can explain it logically, then it is correct. Then people will accept it. It is not wrong. Am I clear? Okay.
Yes.
So let's do another one. Okay. So let's go to same
Import
this one. So here we have three groups. You can see 60 data, 20 in each group. So I have to, sorry, name the variables. Suppose this is mm, score of achievement. I have written A here. And these are the three methods of teaching. So I have group. Here I have written methods. values. I have 1, 2, and 3. 1, maybe lecture method.
Hmm.
Okay, always write full words. Okay, I'm just now
Huh.
I'm writing because now otherwise what will happen that in future when we'll see the output we'll get confused.
Huh.
Okay, okay, lecture method, discussion method, and 3 maybe
Oh, that
mm,
seminar was there.
seminar method. Okay, okay. Now
Hmm.
go to that view. First we'll check the frequency.
Descriptive frequencies method of teaching.
Then go to statistics, mean, median, standard deviation, maximum, minimum, skewness, and cortices. Punch.
Hmm.
Okay. Then
Hmm.
click okay, create API style table. This is the okay, no, not this one. Oh, wrong table. Oh, I haven't calculated anything. Okay. I want to go to the variable view. No, I have calculated. Just let me cross this the
Huh.
frequency. I don't need. Electric frequency. Okay. Now, okay. So this is the table we need. Okay, mean, median, is skewness,
I think there's a bit of a lag.
the deviation, standard curves, maximum, everything we have.
Yeah, no, there's
What
a bit of a lag and your voice was
lab of what?
breaking. So, yes, yes,
Am I
you are.
audible now? Okay. If you think that any table you don't need, you can delete
Huh.
it. Okay. Here we have option. You can delete it like this one. Okay. No. Table. Yes. Just click the delete button. Okay. Because if many tables are there, na, it become very confusing. At least for me. So it's better. We don't need that table. We just need this one. So we have here. Okay. Now we'll do. We check the assumption. Okay. We'll go to graph first. Legacy dialog and box plot. Okay. Simple box plot and summaries by variables. Now cases. Fine. Variables. Method of teaching will be in the column. Mhm. Sorry. In categorical access. This is the back. So we have no
Hmm.
outlet, so no problem. Yeah. Now we go to graph. Sorry. Graph. Let's see dialog. So we can use bar graph here, bar diagram because these are
Variables.
separate
Huh.
group. Okay. Yeah, separate variables and so simple bar summaries for separate method of teaching in the column. Oh no. I've done something wrong. This one how to delete. Graph, legacy dialog, bar diagram. Separate cases. Mm, okay. I got teaching. Method of teaching in the column. So you can see there is a increase in trend.
Huh.
Okay, or we can draw graph in another way also. Bar diagram. Bar. Variable. Define. No, not this one. Okay, just leave it. Okay, and we can other graph if we want to plot. Okay, three groups. Now three groups and variable is method of teaching
Okay.
in achievement. Okay, we can also draw line graph if we want. Simple line. So line represent. Line graph will draw. No, we will not draw because we are not seeing any trend. Okay, so that bar diagram and box plot they are enough. Okay, now
Oh,
go to now we have to check the assumptions. So go to descriptive, explore, dependent. Here we will check the assumption of normality and homogeneity both. Okay,
okay.
so click to normality test, and we so this is untransformed data. So click here and continue. Then we click OK. Okay,
Hmm.
so this is the table we have. Descriptive normality table. So not significant. It means assumption is fulfilled. Okay. Again, we have to use the sample size is large, so we have to use more than 50 separable. So it is not significant. Also, if we test the homogeneity, not significant, so we can use ANOVA easily. Yeah,
Hmm.
these two
Okay.
tables. Okay. So now we'll go to analyze. It is one-way ANOVA. So compare mean one-way ANOVA. And then list method of teaching factor. Go to option
Hmm.
for descriptive statistics, homogeneity or variance. Again, I will click
Hmm.
it. Okay. Then means plot.
Okay.
Then continue. Then post-hoc test. Assumption is we know, so I will go for the Bonferroni test.
Hmm.
I use for Bonferroni.
Bonfire.
No, it's is easier for me to interpret. And if the variances are not assumed, then we have to use game survey. Okay. Then
Okay.
continue. Then contrast I discuss. Okay, just simply click here polynomial and linear. Then continue. Okay. Estimate effect size, continue and then click OK.
Okay.
So here we have the table. And why first I will discuss the descriptive for three groups. That is the reason why I use descriptive. Already we did descriptive test before at the beginning, but there we have total mean of 60. Okay, but here we have separate mean for separate group
Okay.
when we are doing ANOVA one way. You can see for three groups separate mean separate density. Okay, then we have homogeneous Levin test. Already we did this. Then we have okay.
I'm sorry. Your voice was breaking. Can you repeat that?
Okay, descriptive test. We did it in the beginning, but that time it was on
Huh.
60 total n. Okay, but here we have separate mean for separate. And then we did the homogeneity of variance test, 11 test. Then the ANOVA, the final table. See the combined
Okay.
one. This one will consider it is significant. 0.01. This is significant, it's showing significant value. If we click, we can see here. We'll get another table information. If we just click there, double click there. Okay, and anyway, we don't need it, is significant. Then we have effect size. Eta square will consider. So if multiplied by 100, the effect size is 9.2%, which is large. Effect size we have. Post-op test. This is the Bonferroni test. You can see this test have shown the pairwise comparison thing, and all of them are significant. We can see all group differ from each other. It's written here, mean difference is significant at 0.05 level. This is the trend analysis we have. So we don't have to plot as the method of learning is and if we double click here, we can add up data. So we don't have to calculate line block from the graph. We can get it from each dot. Is it clear?
Yes.
And also we have box plot here. But it's better before box plot you will get here again. Before starting your analysis, you draw the box plot. You can draw other graph after that.
The box plot will be easier to see the outliers first.
Need to check the outliers. Yes.
Sorry, your voice is breaking again. Yes.
You can, I have imported, you can export data. Data anywhere. Okay, you can do that. You just have to, just let me show you. Just go to file. Here you have an option export. Okay. You want to save your file here. The same thing in our laptop. In a sense, so you can save that. Okay. Otherwise, you can do that. Like save options we have here. Yeah, save as. And most of the time, what I do, but generally we shouldn't do that, because if you miss it, then your data will you lost your data. I just click this button and just click here, save content. Okay, but this is not the correct one. This is we do it when we're in hurry and we just want to save it. Better you go to file, go to export, and save your data. Okay. Is it clear?
Yes.
Okay. So what do you think? SPSS is difficult or it's easy?
I mean, I will say it has become much easier, because it was very overwhelming even when I was doing during the dissertation and all. But now it does seem like it's something that I can actually do. If the SPSS software itself was available for free, it would have been much easier to practice.
Yeah, that's it. But it's not possible. But yeah, obviously you can download the trial version, and in every university you will have like SPSS is there in system, so you can use it. Like we used to we use SPSS in our university, in their computer, in their system they have, in lab they have SPSS. We can use that. Okay. Otherwise, if you want to use an SPSS, you can download the trial version, and obviously you can do it once in a year, the trial version. And whenever you are doing analysis, please consult the book or the PPT or anything you have, and then you can do that.
Okay.
Okay.